So good day. So I will discuss my answer in activity 6 in analytical chemistry. So number 1, what is gravimetric analysis? So gravimetric analysis is a method of quantitative chemical analysis in which the constituent salt is converted into substance of known composition that can be separated from the sample and weighed. So the steps commonly followed in gravimetric analysis are preparation of solution containing a known weight of the sample. So a separation of a desired constituent, weighing the isolated constituent, and computation of the amount of the particular constituent in the sample from the observed weight of the isolated substance. So in number 2, explain the following properties of precipitates and precipitating reagents. So in letter A, particle size and filterability of precipitates. So precipitates consisting of large particles are generally desirable for gravimetric work because these particles are easy to filter and wash free of impurities. In addition, precipitates of this type are usually purer than are precipitates made up of fine particles. And in letter B, colloidal precipitates. So what is colloidal precipitates? So colloidal precipitates are solid masses formed in colloidal suspensions. A colloidal suspension is composed of particles having diameters ranging from 10 to 7 to 10 to 4 centimeter. These particles are invisible to the naked human eye. So in letter C, crystalline precipitates. So crystalline precipitates are solid masses formed in a crystalline suspension. So a crystalline suspension is composed of particles having large diameters, about 10th of a millimeter of greater. So the effect of the gravity on these large particles is considerably higher than that of colloidal particles. So in letter B, coprecipitation. So in chemistry, coprecipitation or coprecipitation or CPT or co-precipitation is the carrying down the precipitate of substances normally soluble under the conditions employed. So in letter E, precipitation from homogeneous solutions. So the formation of precipitate which is generated homogeneously and generally slowly by a precipitating agent within a solution. So in number 3, why is it necessary to heat and ignite the precipitate after filtration? So the temperature and method of drying depend on the method of filtration on the precipitate's desired chemical form. Placing the precipitate in a laboratory oven and heating to a temperature of 110 degrees Celsius insufficient to remove water and other easily volatilized impurities. So in number 4, the calcium in a 200 ml sample of a natural water was determined by precipitating the cation. So the precipitate was filtered, washed, and ignited in a crucible with an MT of 26.602 grams. So the mass of the crucible is equal to 56.077 grams per mole, plus 26.7134 grams. So calculate the concentration of calcium in the water in units of grams per 100 ml. So by getting the answer, use a formula and get the answer which is equal to 4.045 times 10 raised to 4 grams per liter. So in number 5, an iron was analyzed by dissolving a 1.13 gram sample in concentrated hydrochloric acid. So the resulting solution was diluted with water and the iron was precipitated as the hydrous oxide. So By the addition of ammonia after filtration or washing, the residue was ignited at a high temperature to give 0.5394 grams of pure um, hydrous oxide. So calculate the iron, which is equal to 55.847 grams per mole, and letter B is iron is equal to 2.2. I mean, letter B, the grams per mole is equal to 231.54, and in this number I also use a formula, so the answer we get is, in letter A is equal to 33.34%, and in letter B we get the answer of 46.04%. So in number 6, discuss how gravimetric methods are useful in determination of the following. So in letter A, in organic precipitating agents, so these reagents typically form slightly soluble salts or hydrous oxides with the analyte. So as you can see from the many entries for each reagent, few inorganic reagents are selective. So and letter B, reducing agents. So a reducing agent reduces other substances and loses electrons. So therefore, its oxidation state increases. So and letter C, organic precipitating agents. So the organic precipitating agents are organic compounds used to precipitate some metallic ions, where some cyclic compounds or chelate complex with very low solubility, such as dimethyl glyoxamine. So it's used to precipitate nickel and alkaline medium and with palladium in the acidic medium. So letter D, organic functional group analysis. In functional group analysis of organic compounds, it is assumed that an organic molecule can be considered as a sum of virtually independent functional groups, so whose properties determine the physical and chemical properties of the compound. And in letter E, volatilization methods. Volatilization is achieved by a relatively simple physical methods by which analytes are transferred from the aqueous liquid environment of samples into a vapor phase. The analytes in the vapor phase may then be detected by colorimetric or chromatographic or other appropriate methods. And also gravimetric methods is useful in the given agents because of the quantitative methods that are based on determining the mass of a pure compound to which the analyte is chemically related. So compound of known composition that can be weighed, known chemical composition that can be weighed after calling the precipitate is weighed and the mass is determined. So that is the use of gravimetric methods. So and also you can see my solutions and the file attached in the Google Classroom. So that's all, and thank you.